So I'm Chris Pollard. I am the product manager of Assurity Cloud, and I deal with the performance side of the Assurity Cloud family of products. Next, we've got Nishad.
Hi Chris, I'm Nishad. Been with Assurity for maybe 5 years now. I'm a senior performance engineer, and that's what I do. Live, breathe, and eat daily.
Lovely.
Hi, good afternoon. My name's Alan Raftery. I look after the performance team and all performance aspects here at Assurity.
Okay, and today we're going to be taking a high-level overview of performance testing, what it is, what it can do for you, why you might want it, and whether it's going to be relevant for your particular situation. And we'll be looking at some examples of hard-won experience from the trenches from Alan and from Nishad. Right, so just to set the scene, Alan, can you give us a quick overview on what performance testing is?
So performance testing is essentially looking at the sort of non-functional aspects of a system, whether that's understanding customer traffic across the system, whether that's understanding load across the system, essentially using automated testing tools at scale to either stress a system from end to end, or to hit a particular non-functional requirement, which might be, for example, how long it takes for a customer to log into a system, or how long does it take 100,000 people to log into a system at any one time.
Excellent. Okay, so who is performance testing for?
So if you want to meet your peaky demand, if you're a high volume application or a website dealing with a lot of traffic, or your technology stack is undergoing change, for example, you want to validate the effects of change in the customer base, the size increasing, the cost of there is a transformation in your technology stack, a version upgrade, or if there is any form of perceived business risk from the change in your technology, I think it is a candidate for performance testing. The value that comes out of it can be seen in different ways. There's an interesting example for one of our major clients in the government sector. Of course, we are in Wellington, so we deal a lot of clientele like that. And all we wanted to validate was the login journey. We validated it from close to the data center. It was very performant and quick. And then we moved away from a different geographical location. What we identified was, instead of the traffic going from New Zealand to Australia directly, we ended up going around the world, hopping into Singapore and then somewhere in the east coast of USA, and then bouncing back the traffic. So, it's all forms of interesting patterns that you can learn and mitigate. We kind of solved the gaming problem in New Zealand. People could actually play their games faster here,
Right. So it sounds like it goes beyond just, do my servers run quickly enough, or has my local infrastructure got enough connectivity, through to actual kind of data paths across a distributed network around different regions. Okay, so keeping it nice and high level, why would someone want to do performance testing?
You like a thing off the front page of the newspaper? It's often an area you kind of consider around that. When you think about big systems and going live with new systems, particularly as Nishad said, being in a government town, there's an awful lot of reputational risk going along with a release, whether that's a new website, going online and your customers can't get in, but more than 4 or 5 of them log in, it's not a great look. Often we've had many involvements in large scale programs of work, hundreds of millions involved in program of work, only to find out that if you can't get through that front door on the first day, then it kind of seems like a bit of a moot point in spending a lot of money. So all the really good work that everybody's done can essentially be nullified by not having an optimized system and not being able to meet your requirements. And to add to that, as you were mentioning, optimization of a system is kind of key as well when you're looking at this. It's not just necessarily can all the people get through the front door, but you might have looked at purchasing a system and you bought an awful lot of tech and an awful lot of cloud compute, and maybe you've under-provisioned or maybe you've over-provisioned. So performance is very crucial, I think, in looking at that aspect to understand what is the optimal settings for any particular system.
Okay, so just to drill down for a second on that, when you said you might have over-provisioned or under-provisioned, so you're using it to understand how much provisioning you should need in order to right-size your infrastructure and optimize your spend. So it's not just about keeping the lights on or keeping the system up.
No, exactly. And look, performance testing, like any other facet of IT, looks at how to get the best bang for your buck. So applying like a shift left philosophy, we look to do a lot of performance testing at the architectural stage. So understanding what does an optimum system look like by understanding what the traffic patterns and what the requirement for load across them are. We have had experience where a recommendation from a vendor on what a tiered architecture would be required, with the understanding that there's elasticity and auto scaling involved in that, only to find out that once you implement that, the tiered architecture was probably too low, the auto scaling was not optimized, and it doesn't often work, which is a bit of a misconception that auto scaling will just work out of the box. There's a lot of heating up and warming up activities that happen in that space. So understanding what it looks like as systems come online can often impact, how the customer experience is as well.
Okay, so we've understood a little bit about what performance testing is and who might want it and why they might want it. What are some signals from an organizational perspective? How would you gain an understanding about whether you should start looking at doing some performance testing or engaging with performance testing?
Again, if you get customer feedback that suggests that they're not happy with how they interact with your system, it's usually a very quick indicator. Often a lot of people have monitoring on their systems that will try and tell them, whether we're meeting SLAs, service level agreements, or non-functional requirements for people to access the system. If your monitoring tools tell you you're not hitting them, probably a good time to consider performance. As I said, with a shift left philosophy, as soon as you're starting to build a system, as soon as you're starting architecturally trying to understand how you design a system, that would be when we recommend performance testing comes in. And again, what we'd like to do at that stage is really just understand the risk of performance testing for an organization at conceptual stage. So it allows the organization to not just budget, but to allocate resource in correct spaces, not just human, but computational as well.
Yeah. Thank you. So drilling in a little bit deeper, you talked about kind of after the fact signals, so things like monitoring or traffic limitations, the kinds of things you'll see in a system that's suffering some duress or potentially showing signs of problem, which you might want to get into. Are there any, for things in a shift left kind of way, are there other business signals? What kinds of business scenarios would you suggest lead to benefits in some upfront thinking around performance testing?
When we say shift left, you want to integrate from the design and planning phase itself. When the concept, the whole architecture is being designed, having a performance engineer in there, I think it always helps, because then you can start looking at obvious bottlenecks and signs early in the game. And in another client's example case where we were involved early on, and through this pure paper-based exercise, we could identify, okay, there are certain connection limits and bottlenecks we're going to hit for the anticipated workload. Mm-hmm. And that saves a lot of time in fixing and root cause analysis happening later in the game. Mm-hmm. So the whole shift left kind of comes in with the stage containment idea. And the sooner you find a defect or an issue, the more cost saving there's going to be, and more comfortable you are going to be before your go live phase. Mm-hmm. So I think, yes, starting sooner and not waiting for those signals is crucial, and planning ahead. Yeah.
I guess some of the signals to add to that, Chris, is that we've got Keith here, who's part of our marketing team. Often if you have a marketing drive from your organization, if you're going to send out an awful lot of information that's going to drag people's attention to your websites, then you're going to have an unexpected bump in traffic. Thought process like that going, what are we actually going to do? How are we going to drive traffic? And are we doing stuff from a business point of view that's going to impact the IT side of our business? Mm-hmm. If the answer is yes, then it's definitely have a consideration about that.
Nice. Okay. Are there situations where maybe even in the kind of project planning phase, there might be some equivalent things to that, to say, again, that's a little bit reactive perhaps, but are there things which would be, what types of program or project are likely to encounter things where performance testing is likely to be a benefit to get in early?
Yeah, and as I mentioned earlier, trying to apply that risk-based assessment is kind of key to understanding it, which, again, not rocket science, but if you're implementing new software, if you're changing your stack in any way, if you're altering legacy systems, then it's at that stage you kind of need to understand, do we need performance? And, are we redirecting traffic elsewhere across our stack? Are we potentially adding traffic due to functional implementation? Or are indeed, looking at the opposite, are we reducing traffic, in fact, from our stack? Again, from a planning point of view, are you moving from a local data center to a cloud-based solution? What is your customer interaction and what are your business interactions on a day-to-day basis? So if you can consider each of those as you are during your planning phase, then most likely in a good position to carry out a performance risk assessment.
Okay. So flowing on from that a little bit, when can performance testing occur? We talked about some early signals and some late signals. Is it ever too early? Is it ever too late?
It is too late sometimes. Yeah. As I said, if you're in the front page of the newspaper, it's probably too late. Too early? No, never too early. We like to carry out what we call like a paper-based exercise. So if we can look at the specifications of a system and apply customer logic to that, you can understand then you need to apply performance testing to it. So trying to understand what your system requires before you build it is a lot more cost effective than building it and fixing it later. Right up until you go live, there are chances and opportunities to optimize your system. Even post go live, there are opportunities to optimize your system to get the best bang for your buck. It's also worth considering, a lot of business and organizations, particularly what we deal in Wellington from a government point of view, there's a lot of cyclical activities. So you might find that your systems spike peak at different times of the year. So you might go live with a system that's not going to be hammered for 6 months, and it gives you an opportunity then to actually optimize your system in advance.
Okay. So if you leave things too late, what are the available levers for an organization? So they've pulled in some performance testing a little bit late. It's quite near the go live date. What kind of options do they have to deal with a performance issue?
I have a few examples where I've seen either you have to resort to alternative approaches where you came in too late, you started performance testing, now you have some issues identified like slowness or not quite meeting the expected traffic levels that you're going to expect on that go live date, right? So you see strategies like throttling of the traffic, which means you're just evening out a huge sum of users trying to access your system. And there are mechanisms to just rate limit that and allow only few users at a time. It's a bit like contact center, right? When you call and then you go into a queue, something like that.
Okay.
Or you would be in a situation where you just throw in all the money available or left in the budget into just brute force and speccing up your system to the point where you think, okay, that should be a comfortable position to be in. And we are ready to accept it for a day or two of that spike event that we might experience. And then we'll tone it down, come back to the levels which are more normal for BAU.
Yeah, and look, it's the same as everything I keep saying. Like the earlier you can identify it, the better. You can mitigate risk early in a project by understanding what would be the action if performance, say, failed. It might be that you revert to a legacy system. It might be that you have a paper-based activity that can carry on. Immigration might want everybody in the first week, but actually they have a month to do it. So it could be back to paper-based activities. So yeah, there are different options. But again, if you can mitigate risk earlier, you'll be in a much healthier position.
Right. So basically we're saying you're going to be greatly reduced in the options that you've got for trying to deal with the perceived load that is going to be troublesome. And they're either expensive or they might give a suboptimal user experience or something like that.
Yeah, and I'll go back to the reputational risk. If you spent a lot of money on something and your customers can't use it, it's hard to justify the cost and expense. And it's not a huge overhead often to do the performance, particularly to do it early.
Okay, so if you were to do it earlier, which sounds more desirable, it's going to give better outcomes. What kind of options is that likely to generate in terms of remediations or the runway that you've got to cope with the findings? What could you do?
I think it's project management 101, right? You just want to get all the ducks in a row before you dive into it. And performance testing, well, traditionally it comes at a later stage because you wait for a stable environment You want the features to be or MVP of the product being developed, and you can actually performance test it and have a environment that is production like where you can test it. But engaging early, the answer is not always performance testing. The analysis helps you draw out those features, or you can highlight the bottlenecks early, or if you are going through a massive transformation, like Alan mentioned earlier. You could have many systems which are undergoing change. We have done analysis where there are at least 50 to 60 applications which are undergoing change and are candidates for those changes. But not every would require performance testing. And we would, through the assessment process early on, we have now figured out that we have maybe 5 to 10 applications which actually we put the business context to it, what it means to the business of the big data, and the technical context as well, and allows us to define, okay, these 5 to 10 are candidates. And so the project is prepared and ready, that when the time comes, when the application is nearly ready, we are ready to hit the ground running. Yeah.
So a second ago, you talked about standard practices to wait until you've got a bit more maturity in a project. You wait for an integrated environment, then you start doing your performance work. That sounds like setting yourself up with a bit of a risk, though, because if you discover a performance issue at that stage, you've already built things, you've already architected things, you've got your layers set up, you've provisioned certain types of connectivity, you've got things integrated, right? That still sounds like the cost of change to remediate those performance issues could be still quite high at that point. Would you recommend doing something before that stage, before you even get to having a built environment? So obviously you're not going to run a load against it. What could you do instead?
I think a common practice followed is you start with isolated test runs. If whatever is ready, available for testing, even if it is a feature, you can performance test it to some assumed numbers, or if you already have the details, you test it. You can keep incrementing those features and keep testing. So your baselines shift, and you have been tracking the variance with every change. And that way, when the whole solution is ready, you're probably in a better position. And if something goes in an unsuitable direction, you're likely to be able to pinpoint it much sooner and with a lot more confidence, rather than finding needle in a haystack situation.
Right. So rather than delaying getting eyes on the performance of the system, you've actually built up a picture through measuring smaller units as they're being developed or deployed.
Yes. So that's just one way of mitigating it. I'm sure with different projects and scenarios that can change. And sometimes you have to be creative so that it fits the customer or an organization's way of working.
Yeah. Okay. You mentioned paper-based activities. Is that something you could do earlier in a project life cycle as well?
Absolutely. As I said, as soon as you have some concept of what your project is you want to do, as soon as you start considering architectural viewpoints, that's exactly when you should be considering performance testing. So try to understand what your tiered architecture is going to look like. Understanding technology of the system that's carrying out the functions, quite key as well to understanding where you're potentially going to be creating your problems later on. And understanding how you can flow traffic as well, can identify bottlenecks very early on, which is, again, a cost saving. I think as we've all had experience of, when you are dealing with an issue that's being designed in and that's either in production or just before you go to production, optimization of that piece. I mean, it can just go on. And it's very hard to consider budget for remediation of issues because, as Nishad said, it's kind of a needle in a haystack sometimes. If you haven't got a clear view as to the components and how they perform, then as a combined stack, you are basically picking it apart to try and understand the problem. And then optimization of any piece of code can go through iterative cycles for a long time and be quite costly too.
Okay, so it sounds like the underlying theme is that the earlier you can get some performance oversight onto a piece of work, onto a project or a program, the better your outcomes are likely to be. And that might even be identifying that you don't need to do any more performance work, right?
Absolutely. As I said, if you can assess it at an early stage, then you can identify whether you actually need to carry out. As a testing is just a mitigation of risk. Performance is no different than that. So if you can identify your risk early enough, then you can mitigate it through acceptance or through actions.
Okay, right, moving on. So before we get into the execution of the performance type activities, from an organizational perspective, what are some of the things you need to get in a row? What ducks do you need to get in a row in order to embark on a performance activity?
I couldn't emphasize more on this one, and that is non-functional requirements. It could sound very straightforward and a very common term used. And I think in the industry, a lot of people like to go away from the non-functional requirements to make performance requirements as a functional requirement. It's a functionality. Performance is also a functionality for you. But what it means is the ability to measure success and allowing the possibility of risk mitigation. NFRs give you those benchmarks and comparison points which allow you to understand, okay, is the system performant? What is our criteria for performance? Quite often you come across situations where they're not clearly defined, or you'll see the functional requirements are very thorough and detailed, and they are refined early in the game. I would say non-functional requirements are equally important if you want successful or more meaningful outcomes.
I'd add to that, the main requirement is to pick up the phone sometimes. Often I think if people believe that there's a whole quagmire of information that they don't have, that we can't actually progress with it. My view is that if you have a belief that you need performance testing, or you're not sure if you do or not, reach out. And there's going to be experts out there who can advise you on the assessment work you need to do, and then identify the requirements that you will need to present back to them or provide in order to have a successful testing outcome. But if you don't have anything, don't be afraid. Just reach out and get somebody to assist you with it.
Okay, so once you've got your non-functional requirements sorted out, what's another activity that you would be looking to do in preparation for running some workloads?
So the keyword that you use there, Chris, is workload. And that's kind of the next step. You want to identify workloads. You want to sort out what flows and scenarios you want to simulate. And then you're looking at how are you going to simulate, or where are you going to simulate this from? So if I just touch upon the first point, which is the workload side of things, it's very important to understand what flows and how frequently they are going to be accessed by the real user. Mm-hmm. Talking about a login page or a home page or a landing page, in a minute, how many users are going to access that page? And then there could be combinations when maybe X number of users log in, maybe Y number of users are trying to perform a search operation, or a subset of that is going to try and add to cart some product and they are going to check out, for example. So there are different combinations and flows. So for performance testing, understanding these models is quite crucial, and more accurately you are able to represent that and simulate that in your test, the more realistic outcomes that you can get. So the risk of not doing this or not doing the analysis for this appropriately could be that even if you ship it and you start performance testing soon, but you have simulated something which is probably not going to be representative of your production, then you still have that risk of issue occurring. So I think this is quite an important step in that sense.
That makes a lot of sense. Okay, so you talked about users. Clearly, many customers have customer-facing, actual human-facing interfaces or sites or products. Does the same apply for non-human clients, as it were? So when you've got services or technical integrations across different providers and systems, do you have the similar kind of thing?
Absolutely. When you're looking at a system, its interaction, we talk about it from a customer experience point of view because generically people use systems, but you test out an API there, which is basically just integrations within the system. It doesn't have to have a face at the end of it.
Okay.
And in fact, though, as I mentioned earlier, it's kind of automation, but it's not automation like a traditional scraping your screen automation. It's code that will simulate user loads directly at API levels.
Okay.
And one of the common challenges that we face is, where do we get this data from? What are you going to do number crunching on? And the most common advice that would be given is, look at your historic data, look at production patterns if possible. Mm-hmm. Let's do the number crunching on those and let's recreate those. But then the next question could be, we're just going live for the first time. It's a brand new system. There's no history. And so that's where the business context helps. If they are running a marketing campaign, then there are certain expectations of customer acquisition numbers that you can play with, or there could be other competitive apps or applications or systems which could help you as a reference point. So the information is always out there. And circling back to Alan's first point, you just pick up the phone and start early. Yeah.
Leverage some experience.
Yep.
Alan, you mentioned like kind of coding here. Is that another part of the preparation step? Some kind of creation or working around the code and the automation side?
Yeah, so I guess once you've understood what you're trying to achieve, you're trying to achieve 100 people logging into a system at any one time, you then need to simulate that load. So it's an automated suite of tests, essentially following a workflow through your system, whether it's logging in, checking your bank account, logging out, something like that. So it's an automated script you write. And then the idea would be that you would run that at scale to simulate a lot of people carrying out the same activities. When you look at performance and people think about coding, it's quite a small piece of the overall puzzle. Yeah. So doing all the workload modeling is where a lot of the effort goes in. And then likewise, analyzing the results. So once you've got all the information, you've got all of the reams and reams of data that you need to go through. Scripting can get past it, you need to do it, but it's only a small part of the overall process.
Okay. Cool. And the results of that scripting, what do you get out of that?
The results of the scripting is you get a nice script. You then essentially, like in the automation piece, you press play on it, you run that, you'll get some feedback. And that feedback can be whatever you're looking for in terms of response times, different parts of the system. So essentially you have your script, you apply that, a test harness over that, which will then generate load. So simulate that single test at load.
Yeah, like Alan said, scripting is a small part of the overall performance engineering effort, but it has to be efficient enough to spit out the right amount of data and information which will help that analysis process. I would always come back to this point where you want information from your test results which will make sense to your stakeholders. So while it assists an engineer in analysis, it should also help the engineer to translate that information for different layers of consumption. It's a common saying, you can't test your application code efficiently if your own scripts are suboptimal.
So presumably there's quite a lot of, or potentially quite a lot of actual load generating compute or systems required to generate that load to exercise the systems under test.
Yeah, very much so. Look, that can be something as simple as just having your own machine with the software on it and running it, and you'll get 2 or 3 users before you start finding your machine running a bit slowly. You can then add 400 laptops in a row if you want and try and simulate that, but you may as well just get a human interaction doing it at that stage. So we often just have virtual servers, put the tool sets on it that we use to run the scripts, and then we apply the compute to generate that load, because it does generate quite significant overhead. And I guess one thing as well to sort of be considering when an organization is generating such load, they can have adverse effects on their day-to-day business, let's say. So if you've got limitations on bandwidth, for example, and you've gone and asked a performance service to run some tests, you might want to consider when you're running those. If you run them during your business hours, you may directly impact your actual business. If you run out of hours, you might be having a better outcome, but you might not have a realistic experience. But also you might actually want to talk to your service provider and understand what are your limitations. So you're not maxing out your bandwidth, which can easily happen when you're doing things like stress testing, which is part of performance testing to understand exactly how far you can go.
Okay. So I guess that flows into a wider question around getting your systems under test, your environment set up for that workload testing. Are there any other things that you need to do in that space? Are there any situations where you've seen that go wrong?
Where we've seen a system go wrong or an environment go wrong?
Where there might have been unforeseen interactions between the system under test and wider business systems, for instance?
On 1 or 2 occasions, yeah, unfortunately. We have had history of where we've worked on certain client sites and they had a shared infrastructure. So their test architecture and infrastructure was sitting on the same space as the performance or their sort of production tier. So when we exercised the load against the test system, inadvertently we were running across the production system, which basically stopped all production traffic getting through, which meant a lot of phone calls ringing and that us getting a call at some ungodly hour in the middle of the night to ask us to stop running tests because we were killing your system. which is quite interesting because I think if we had done that architectural review at an early stage, we would have identified, oh, hang on a second, we're going to inadvertently impact your production system because you have it hooked up to your test system.
Right. So that was an unanticipated side effect.
Very, very much unanticipated. It did lead to quite a few things that came out of there. I think some organizations have gone back and looked at their architecture based on some of that findings.
Good stuff. Okay, so those are the things that happen before you start generating some load and actually doing the activity. I know you say the actual running of the load is quite a small component compared to that analysis up front and then the analysis of the test results. But briefly, what kind of things happen during the actual kind of loading up phase?
You monitor the test, and probably the whole team is waiting for you to come back with outcomes and results. Mm-hmm. And then sometimes it's a very collaborative effort where while you are running the test, you have different teams, like it could be the DevOps or infrastructure team, you have the architects, you have the network engineers, and you have the developers all in one call when you're simulating the scenario, and you have eyes on the price on every component being tested. And that way you can spot the anomalies quite immediately and start taking actions and regroup and take decisions and retry it after making fixes. So you can simulate different scenarios, and this is all driven by that workload model phase that we talked about. So you could run the peak tests, you could run the extended duration tests, you could simulate spikes. They all give different information. The idea is it has to be realistic, and the information is captured in a way where it could then be processed and represented back to the customers or the teams involved in that phase. One effective method which I've seen recently is collaborative effort works really well. I think change management, a lot of organizations invest heavily in change management tools. It's always tracked, but then how closely that it is monitored and how that impacts the performance testing phase is sometimes missed, or there's a gap there. But the good part I've noticed of late is we were running tests, we were recording every change that was being applied to the system, and there was a playbook being prepared in parallel, which allowed the engineers to be ready and aware of what they need to apply to the end state of the system and not miss out any requirements after all this effort has been made. As that is also a likelihood sometimes where you performance tested, you tweaked it, and when you're going live in production, we probably missed one configuration, and that became a house of cards situation.
Okay, so there are limitations on how iterative and responsive you can be. So just rounding off the whole kind of art of what it looks like, you've run some load, you've generated a whole load of data. What's the kind of closing out step on that? What does that look like?
Analysis is, I think you need to have an eye for pattern recognition. You need to look at aggregated numbers because if you're dealing with large quantities of data, but at the same time, you want to look at the raw patterns and distributions that come into play. I think it's a lot of mathematics and some of the principles that get applied that overlaid with experience of working with different types of technologies and platforms. And what are the common patterns that you see in this data? How does that translate into issues or good stories? And then effectively playing it back to your clients or customers or engineering teams.
And I think, yes, definitely there's an awful lot of technical aspects of it, and there's an awful lot of technical parts of your report. But I think one of the key things as well is to be able to understand that and raise it up a level so that key stakeholders across the organization, and maybe the ones who are engaging to look for performance, are able to understand what the information is you're playing back, whether that means your system's good, bad, and different. Yes, you will have architectural viewpoints, and you will have a lot of deep dives with potentially multiple vendors, all trying to figure out where a problem may or may not exist. But being able to articulate that back to people who maybe are not of the technical persuasion, who need to make a decision on the program.
Do you find that you can distill things down to a kind of go, no-go kind of decision, or is it normally a bit more involved than that?
Depending on the project, and depending on the program, and depending on the maturity of an organization. An organization is well versed in performance testing, then often you can bring them on a journey and you can share graphs, you can share technical details, and they'll understand it, and then they can make a decision pretty quickly. Where maybe the maturity isn't there, or it's a first time engagement, it's often really considering what is that customer experience, what is that impact, what is that risk that you've tried to mitigate, and that will drive that decision of whether the test was successful for them and it's a go or no go decision based on that.
Okay, we've seen what the life cycle of doing performance engineering looks like, all the way from the initial planning through to building the scripts and understanding the kind of architecture, paper-based activities, running the actual loads, and then analysing them and making decisions based on that. Folk who want to start building a performance practice or performance activities into their delivery, what kind of options exist for that? What could that look like?
I guess there's a couple of options, really. Again, depending on the maturity of your system, your organization, you can build your in-house team. You can have performance engineers working within your own organization who will drive all your performance testing, work with your architects, do all of those wonderful things like shift left philosophy and thinking, and then look to the future and carry out all your testing. You can, as I pick up a phone, ring an engineer. There's lots of them around New Zealand. They will come in and again do the same activities. And then sort of thirdly, you'd be looking at performance as a service options, where somebody will come in with the performance engineers, but also bring in the infrastructure for the test harnesses. All of the cost overheads that you would consider internally will be managed through the service. It's probably a quicker and easier engagement depending on what you need. Again, if you're building out a 5-year program of work, you may want to look in-house. If you need some cyclical activities, it may be an engineer. If you're looking for partnership to provide leadership and governance and performance space, you might want to look to a service.
So it sounds like a bit of a build or buy kind of scenario. So you can either build your own team if you're going to have an ongoing kind of performance need, or you outsource it in some way.
Yeah, absolutely. And I think they all have pros and cons. Won't go into all of them here today, but having an in-house team, it's the overheads of managing and owning that team. Having a service often brings future proofing and future thoughts on how performance is and optimization, which you can kind of lose when it's an in-house piece. And then just consulting, getting people in to do a job works really well, and it can fit the needs at a certain time.
Excellent. So just before we wrap it all up, I'm going to do a slight bit of a kind of vendor segue here. Assurity has their own cloud offering, which runs a whole load of different workloads. Where do you see it fitting in with our performance offering?
Performance and services is our preferred option. We have a number of engineers at Assurity who work together as a team. They drive each other on as a practice, whether that's working off legacy systems or understanding what the future of performance testing is. Considering those questions, which is nice.
Okay. And some of the benefits of using the Assurity performance test as a service?
Well, one of the performance tests as a service that we provide that I have seen myself be hugely beneficial is just speed to market. You can have your test harness stood up. You can have your load capacity, your virtual users all set up really quickly. You can turn it on, turn it off as much as you need. You can have your own viewpoints as to whether you want to run it in short bursts or whether you want to run it over a period of time. For me, it works because you don't have to worry about patching it. You don't have to worry about the upkeep of the harness or your own data center. You're also supported not just by performance engineers, but by cloud engineers who support that system. So once you're getting expertise in the area, you're also getting a general level of IT expertise that has many, many years of experience of building up the service.
I think for me as a consumer / facilitator of that service, I feel it brings in a lot of flexibility and scalability in how you operate. Like, you're not bound by limitations of some of the standard offerings when you go out in the market for that compute capacity and support. We've seen we can adapt to changing requirements, scaling to clients' user demands or user simulation demands, or if there is a change or limitation in the architecture or technology stack, the support from the service allows you to quite immediately start looking at that change and then with a quick turnaround time, implement that and keep the things moving rather than being bound by it and restricted by it. Because I think the key of that service is the outcomes for the customer and client. And I think, for me, those are the highlights.
Right. And I guess because it's a kind of private offering, you can do things like having access to private networks. You can set up VPNs for back-end testing as well as just being limited to publicly exposed endpoints.
Yes, exactly. And then we've done it, right? It's a proven implementation. You can create your private network channels, or you can be a real user coming across the internet. You can also distribute your traffic as if you're coming from different sources through multiple IPs, or you can increase the channel bandwidth to accommodate large sums of data. And you don't want to be bound by the limitations of your harness, because then you can't test the limitation of the platform under test.
Yeah, absolutely.
I'll play devil's advocate here if I can for a second, because look, there's many solutions out there to meet your needs. There are online solutions for virtual users that you can purchase and run tests depending on your needs. From my point of view, personally, working with Assurity Cloud, some of the great things are just the flexibility on how we can meet our own requirements and how we can design our tests and design our harness for use at each client site. So just having that bespoke nature and not being tied to either virtual user limitations or time boxing activities. So for me, that's one of the key ones. But there's definitely lots of options out there that can be considered.
Excellent. I feel that we've covered a lot of ground there. I think we'll call time on it. Thank you very much.
Thank you.
Thank you.